Hi, it's teardown time. I thought I'd tear down my original, like almost 20 years old, I think, Uniden 40 channel UHF CB transceiver, CB radio thing for all you CB aficionados out there. I'm sure there's still a few. I used to use these for canyoning and bushwalking and stuff, and one of them, ironically, based on my last video, actually died with the battery corrosion. It was completely cactus, and this one got a bit of treatment as well. But I thought we'd tear it down, and the reason is because the kids just got some of these. Isn't it cute? Like, I thought this one was really small when I got it, like almost 20 years ago. And, I thought it was remarkable. Look how small these things are now, because they used to be like big bricks. But look at this. This is insane. This is exactly the same thing. It's a half watt, 500 milliwatt. This one's an 80 channel UHF CB radio, absolutely tiny. I mean, look at that. I can almost cover that entire thing in my hand. So I thought we'd actually just tear both of these down and have a look at the difference between, like, essentially 20-year-old technology and this modern one. I don't know how long it's been out, but the remarkable thing about this is that you can get this for like 15 Australian dollars. 15 Aussie bucks. That's what, 11 Yankee bucks or something like that. This is retail from a shop. And these are top quality Japanese brand Unidens, although they're not made in Japan. This one from 20 years ago, made in the Philippines. I don't know why Philippines viewers, but designed and engineered in Japan, and they love to brag on their website now about their, take one of these things apart and take a look at the superb build quality in them and everything else. So I thought, I don't know how long this little tiny little kids model's been out, but it's basically exactly the same specs as this one. Half watt, 500 milliwatts, and it's a 3 AAA battery. It's got a USB port on it, so you can use rechargeable nickel metal hydrides. These ones are, of course, to get the insane price point of like just over $10 US. That's not retail, but that's, shop price, what you can buy them for here in a bricks and mortar retail store. Anyway, these ones are made in the People's Republic of China, the PRC. So but the other ones, I might have a bonus teardown at the end of this too. Originally Philippines, and now these super cheap ones are made in China, but their higher quality ones are not made in China. So anyway, I thought we'd check it out. Let's go. And you might be able to see maybe a bit of corrosion in this one. This one actually survived, but another one didn't, unfortunately. So maybe 4 screws there. This is for a belt clip attachment, and it's got a lanyard and everything else, and this is for microphone and speaker up the top. Anyway, I want to see, the improvements in technology over, say, the last 20 years between these two things to miniaturize. There was a model in between, which was a AAA version of this one, and it was smaller again, but this is just remarkably small. It's just going to be, I can almost actually see down in the PCB in there, it's just going to be a single board solution, but how they can do it for so cheap. And, like, why would you buy a one hung low $2 store cheapie when you can get these designed and engineered in Japan, top quality Uniden brand, even though these are like little kids ones, but you can get these for like 15 Aussie bucks each. It's just insane. Don't know why you'd buy the cheapies, because the performance isn't there. Because if you ever bought one of those, little novelty CB radio things, they've probably just got a couple of driver trannies in there and that's it, and they're just absolutely hopeless. Whereas, these are top quality design and manufacture, especially for kids. Jeez. And we're in like Flynn. This top case just popped right off. It's got the mesh there to protect the speaker, the rubber membrane, microphone, little mini speaker with its mylar cone, and copyright 2000. So, yep, that makes it near on a 20-year-old design. So, looks like it's a multi-board construction. Of course, I expect this one to be single board construction to get the cost down, because I think these ones, from memory serves me correctly, like you paid like $150 to $200 each like 20 years ago for these things. They weren't particularly cheap, that's for sure. And there's the bottom of the main board, and yep, that looks like it was manufactured in the early 2000s, no doubt about it. And Uniden, there you go. It's a, can we get the right light on that? It's a UC2605. Can't find any info on that. Probably a Uniden custom part. Of course, that's going to be doing all of the, the LCD stuff. So that'd be, some sort of micro or, custom thing, maybe. Is it doing a lot of the, because there's analog stuff on here. Look, we've got Japan Radio Corp and some of these other parts which are kind of, they almost look like hand silked on there, pretty much. Like, it's a bit how you doing. Look at that. So a whole bunch of discrete passives, a little watch crystal down here. So that one, of course, that's not going to be an actual watch crystal, 32768. This doesn't have a real-time clock in it. That'd be a higher frequency. But yeah, that's potentially doing a lot of analog-y goodness. So that's got to be some, a custom Uniden ASIC, I would presume. Anyway, board-to-board interconnect. The rest of it, here's our transmitter and receiver up here. So it's going to be, a little bit of shielding on there. So we'll get that off and see if we can get that board out. So that just comes out with one screw holding down the antenna here. We might have a look, take a look at the antenna, but this is interesting. Why have they got just that metal there sort of bent over, and that's insulated as well? So I'm not sure what the deal is there. Anyway, ta-da! There's our bottom can. Oh, geez, we won't find all of this inside our new design. No siree, Bob. Ta-da! There's our antenna. 477 megahertz equates to like a 0.6 something meters. So is that, when you stretch that out, that's not going to be 600. So that'd be a quarter wavelength jobby, would it? Anyway, little just spiral wound there. Nothing special. In fact, quite a few trimmers. 1, 2, 3, 4, 5. 5 trimmers. Thank you very much. There could actually be more on the bottom because there is a substantial amount on the bottom there. So we might have to desolder that can to see the whole dog and pony show in there. But yeah, there's a lot of effort that's gone into that. So I'm going to be interesting to see how they miniaturize this, because you can't make all of this. Like, you can't just duplicate this design and make it a bit smaller, like, with all the same parts and everything for, and sell it for 15 Australian dollars. It's just crazy. So, but of course, back when they were designing these ones, cost was a little bit of an object, but, not for these like kid toy ones. Although this is not a, it's designed for kids, but it's not a toy. It's a proper 500 milliwatt unit, and it's going to perform exactly the same as this. And this is somehow all embedded in there, plus all of this as well. And here's the board with the shield removed, and ta-da! There's the bottom side. We've got ourselves a intermediate frequency IF amplifier here. So it's a traditional multi-stage amp configuration using different chippies. This beast looks really hard and ugly to get off. So yeah, I'd have to leave that if I want this thing to still work. We've got our two separate crystals here, and as I said, lots of trimmers on the thing. Oh, very old school analog, RF amplifier and receiver type design, all embedded inside there. So I'm going to crack this one open, see what's what. 4 screws on there, should just lift off. And sure enough, this is just going to lift off. Aha, even that comes, splits on the antenna there. Just the spiral wound antenna. Oh, nothing's changed, and there you go. And sure enough, to their credit on their website, they claim they don't use any internal wires or anything, and they don't have glue holding things together. They put a lot of effort, and they boast about, their design manufacturability. And sure enough, I really like the solution for the battery contacts there. Isn't that really nice? That just goes down onto these large pads over there. Absolutely brilliant. But look, oh, geez, there's not much in it, is there? We've got a can over here, which is our complete RF front end, and that's our push-to-talk switch. Look at that, little tactile switch, right angle PCB like that. soldered on. You've seen me talk about right angle boards like that, and you might think you're going to come a gutser with the mechanical stress on that board from that, but no, I'm sure they've done their engineering. It's probably soldered on the bottom side as well, and that'd be tough as nails, let me tell you. Even though that looks like a 0.8mm board, maybe 1mm. And if you're wondering how they get away with a shorter antenna, the winding on that is actually larger diameter, and it's squished together. It's got more turns in there, but the exact wavelength would be the same. Hang on, they boasted about no wiring, but I see wires going off the speaker. Oh, come on. Hang on, hold on to your hat. Look at this. Solder ball alert. Warning, Will Robinson, that looks like for all the world like a solder ball. Yep. Oh, no, they got it made in China and they've come a gutser. But, you know, what do you want for the money? So apart from our little solder ball, there we go. There's our antenna input there. Once again, it's all on the main board. It's basically single board construction. I'm surprised they, didn't put a right angle tact switch in there, but I guess they thought that would have been better. Anyway, May 3rd, 2018 is the revision of this board. So there's the main chippy down there. It's got absolutely no markings whatsoever. It doesn't look like they've been rubbed off. It looks like they just never had markings on it. That's almost certainly a Uniden custom ASIC. That'd be doing all the fancy-pantsy business as well as driving all the user interface. That'd be our little charge controller down in there for the rechargeable batteries. And of course that job there is our speaker driver. It's a dead giveaway because, well, it's driving the speaker. A couple of miscellaneous trannies around there, but it's all under the can. If you want to see the good stuff, I'm going to have to butcher this. Sure enough, there's absolutely nothing on the bottom side there, although they do have a little bit of heat sink, and that is for the can under there. So that'd be our transmitter. They're just, because it's 500 milliwatts, it's no slouch. Little through-hole mic there, and geez, but you can really see how they got the cost down compared to the original. No, we're in like Flynn. There we go. It just had a top cover on it. Absolute beauty. Oh, we can see the chip. It's upside down, but all the electrons are going to fall out. Okay, so what's going on here is this is clearly our RF power amplifier, and you can see how they've got DC power coming in here, inductively coupled. That's like par for the course for these type of inline RF power amplifiers. We've got ground and the positive up here, so this has to be the input pin over here. So follow the money under there. So I'm not entirely sure what that little SOT23 jobby is there, but anyway, there will be an RF out. Looks like, oh, that's, yeah, is that it? That'd be the RF out pin going there into the 500 milliwatt inline power amplifier, 500 megahertz of bandwidth, that's all they need. And then this little inductor here, that goes to the output. Now they need to feed back to the input, so obviously they're tapping the input at this point here, because you need a receiver, of course. So there's an inductor, just got some diode protection there, have we? And that, ta-da, follow the money, that would be the RF input. And then what this line is doing there, I'd say, there's a couple of passives in there. I reckon that could be some bias line perhaps. And there'll be a matching network in there as well, and there's not much to write home to your mum about outside here. So that is the entire RF section of a CB radio. That's insane. So there you go, all of that there all now fits into there. Remember, this is the same class amplifier, 500 milliwatts. All that squeezed into the magic of all that, with a couple of external trannies there, and Bob's your uncle. It's all in the one chippy, and this is complete analog in and out. I mean, with DSP and everything. Insane. So this single chip solution here wasn't even a dream, wasn't even a figment of the imagination of the designers of this one. Anyway, we need to find out what this jobby is. It's an 1846S. Let's go to the videotape. Now, it took a little bit of doing, but I found the data sheet. Now, I'm not sure if this for actually this particular one we've got here. I'm not sure it is because I think there's multiple manufacturers for this. So I'm going to assume that RDK Microelectronics, never heard of them, are the originators of this thing. Now, the interesting thing here is that, check out the date. It's 2009. This chip's been around for a long time. It's confidential. Shh. Don't tell anyone, don't give anyone the link to this video, that's for sure. And it's a single chip transceiver for a walkie-talkie. Ta-da! But yeah, it's been around for a decade, so that's really quite remarkable. So if anyone's seen any older designs use this, please let us know. But it's got everything. It's got an on-chip 8 dBm power amplifier. It supports 2 frequency ranges, 400 to 500, and the lower 134 to 174 as well. It supports the dual bandwidth, so that's the difference between the older 40-channel bandwidth allocation of 25 kilohertz and the newer 80-channel allocation of 12.5 kilohertz. Supports multiple clocks, digital audio frequency, auto gain control, Vox. It's got built-in CTCSS. It's got like DTMF and all sorts of stuff, auto RX sleep, and it's got general purpose IO and all sorts of stuff. So the thing is, if you search for the other number, I was able to pull up this data sheet in quote marks, the AT1846S. It's the same 1846, but there's no manufacturer, no nothing. Everything's the same, and they've just got the one block diagram, and that's it. There's a low noise amplifier. There's an RF in and an RF out, just as we saw before. We've got our power amplifier. Then it's got a variable gain power amplifier, driver, VCO, synthesizer, all that sort of stuff. And it's microphone direct straight in. So the other microcontroller has nothing to do with the audio or analog aspects of this at all. The audio frequency out goes directly to the speaker power amplifier chip, and the micro here just talks. I'm not sure why it has both an SPI bus and an I2C. I guess, do you need both, or does it let you choose it? But that's it. That's it for that no-name data sheet. So I assume like there's multiple clones of this chip. Power consumption, basically 50 odd milliamps, both receive and transmit, because the power amplifier is the one doing all the, the transmission power, the 500 milliwatts. It's adjustable from -2 to 8 dBm there in direct output power. Of course, we want 500 milliwatts. You could drive the antenna directly with this thing if you're happy with your 8 milliwatts, but yeah, that's not going to get you far, tens of meters. They might do this they might use this chip in really low end, like super low cost ones. If you think this is low end, they might use the even cheaper low end where they emit the power amplifier chip. Who knows? And we've got a typical application diagram, and yeah, here's the RX-TX switch over here, and that's the RF input there, and yep, there it is. There's a bias. So that was driving the power amplifier. That was the extra line that we saw there, and then it just gets that analog power there via that inductive path there, so that the RF can't. They have the inductor there, so that the RF can't sneak back out. But apart from that, it's pretty easy. It's just GPIO. So it's good that it's got GPIO, because you might want to hook up like a little 8-pin micro to this thing, and then you can use the GPIO on this to drive it. So yeah, that's about all she wrote though. But the other thing is, we've got the full programming guide as well, and this is how you program it via the I2C or SPI. Okay, it sounds like you can use either SPI or I2C. Take your pick. I don't think you need both. So that's really flexible depending on what your micro has. So that's really cool. So you can set a ton of stuff. You can set your start frequency, the RF band you're using, the reference clock frequency, voice channels, bias output voltage to bias your RF amp, sub-amplifier settings, SQ, that'd be squelch, would it? I'm assuming. Vox, eliminating tail noise, DTMF codes and things like that. So FM deviation, RX voice range, it's pretty comprehensive. So there's, you can toggle your GPIO, ST mode, whatever the heck that is, I don't know, something to do with Vox, is it? And various timers and stuff like that. It's pre-emphasis, de-emphasis filters, it's pretty comprehensive. Wow, you could really have a field day with this. Everything's here. So you could certainly, there's no reason why you can't design your own walkie-talkie using this thing. That's assuming, of course, that you can actually buy this sucker. And a quick check showed it's not available from the usual stockists, even the more obscure ones. So, I don't know, you might have to go to someone on AliExpress or Alibaba who's got, you know, got a reel of them sitting somewhere. Or, you know, go, I don't know, check out RDE Micro. Well, it turns out that LCSC is actually an RDA microelectronics dealer. So, yeah, they specialize in all those, but they don't have this particular model chip. They've got the RD5807. Yeah, they don't carry this particular one. But apparently Arrow Electronics is one of the official stockists as well. So you could get your hands on the chip. They're just not, you know, catalog supplied. So yeah, this could be a really cool little chip to, if you want to roll your own, or have to roll your own, sort of like a RF interface, it's worth looking at. So this is how they're getting the BOM cost of this thing down. So this chip has got to cost like, you know, 50 cents or something like that. And the microcontroller, you know, it's probably like a 20-cent micro or something like that. And, you know, the headphone power amplifier is like 10 cents. And, you know, like the total BOM cost of this for 15 Australian dollars in the stores here, like the BOM costs, they have to be making this for under $5 US, like complete. Otherwise, they're not making money on this. It's just nuts. Now, as a bonus, I thought we'd take a look at this bad boy. It's the UH750. This is a professional grade one. It's waterproof, dustproof, and it's a 5-watt one. And the size is basically smaller than my original 500 milliwatt jobby. There you go. It's actually, it's smaller. And I think it's, you know, about the same thickness. But yeah, this is 5 watts and none of this plastic rubbish. Oh, die-cast alloy. Beautiful. This has got a rechargeable lithium-ion battery and none of this made in China rubbish. This is made in Vietnam. I don't want my Vietnamese viewers, so that's, you know, that's interesting. But, oh yeah, this one's built like a brick dunny. Unbelievable. This one's designed to survive harsh Australian conditions. Oh, the screws, look at that, into die-cast alloy. Oh, it's beautiful. Oh yeah, now we're talking. Look at the die-cast front on that baby. Oh, absolutely brilliant. Waterproof speaker seal around there. Fantastic. We've got a seal around the LCD and whatnot. And you can potentially see the O-ring seal around there. But oh, look at that die-cast case. And yeah, it weighs a ton more than the other little chintzy plastic ones. Although, of course, the Uniden plastics, even this tiny little kids one for, you know, 15 Aussie bucks, you know, it feels really quite rugged. Like you could smash it around and do whatever, and it's, you know, it's just not going to break. But the plastics on this Chinese, low-cost Chinese one don't feel as good as my original one that I've been using for, you know, almost 2 decades now. The plastics just feel better quality, but it still is plastic, whereas this, die-cast alloy all the way with LBJ. Well, the bottom of the board, look at this, chock-a-block. There's our main micro. We've got a sticker on that, so that'll be a newfangled flash micro by the looks of things. And we've got a board-to-board interconnect here. There's our crystal once again. It's not a watch crystal, so that'd be the main external oscillator. And bingo, look down in there. We've got some more discrete stuff like we saw in the original design from a couple of decades back, and got little, you know, little bodgy stuff going on, little link wire going over there. So, like, oh, hang on, that's come off. What's going on? That's supposed to be on the can. Oh, that's a bit how you doing. Oh, quite disappointed, Uniden, after all your bragging about, you know, no point-to-point wiring and stuff like that. And unfortunately, in this one, they've tried to solder to some can over there, and it hasn't taken. And I swear that hair, if you're watching this in HD, you should be able to get that. That hair, that is not mine. So someone in Vietnam, that's their hair. They left their little calling card. Oops. Anyway, whoa, look at that. Deep down there in metal die-cast chassis. Oh, yeah. Actually, it looks like I'm not going to be able to get this bottom transmitter board out without taking off without desoldering all this. It looks like they solder this board in after it's assembled. So they just hand solder those in. So unless I go desolder all that, I don't like getting in there. This is my good 5-watt jobby, and sorry, but I don't necessarily want to go hacking around in there. Anyway, you can see got the main crystal down in there, and it's certainly yeah, they've gone back to discrete stuff in here. None of that little cheap ass single chip solution. Another can down there. So very different design thoughts when you actually go into designing this, because you're obviously, you're building this to have a BOM cost of like $5 US. They would have had a very strict target on their BOM cost for this thing. And then once they saw this chip, oh, that enables, the low BOM cost market, and they went after that, which is often the case. A company will come up with a nice little chip, and then a whole bunch of companies will seize upon that and actually make a market out of it. But sometimes it's the other way around. Like, I've worked at companies where we have approached specific manufacturers of chips and gone, hey, we'll buy a couple hundred thousand of these chips if you design us this variant of this particular chip. I'm talking about my underwater sonar stuff and 24-bit ADCs and things like that. So DACs and ADCs. And they would make them specifically, or target them specifically to one or two customers, big customers. And that's a custom Uniden job, UC3476 there. So, yeah, they're not using the original one from a couple of decades back. But, yeah, once again, they're rolling their own custom ASIC there. That'd be doing all the LCD driving as well as, yeah, you can see it up here. That goes up to your LCD module up there. So it's doing all that, as well as, curiously, doing some analogy stuff. They've got, a few pots, 1, 2, 3, 4 little trimmer pots around there. That's interesting. So there you have it. That's a very interesting progression from a design from around 2000, so 2 decades ago now, and, fairly expensive and fairly discreet design. Sure, it's got lots of integration in the custom ASIC up here, which drives it all, but, all the power amplifier, that's all discrete type stuff. And then, cue like 18 odd years later, we've got this thing, which is converts all of that into just this. Absolutely remarkable. I know it's, just people with mobile phones, whoop-de-doo, right? But, I just think it's amazing that they can make that for probably, what, $5 US BOM cost, and sell that in a store in Australia for 15 Aussie bucks. Unbelievable. And then this would have been designed around a similar time, and they've gone back to like all the more discreet type design, probably because it's 5 watts. Okay, this one's only 500 milliwatts, but 5 watts, gone back to your more traditional design that we saw over here, especially for the RF section. It's very, and probably quite similar if you get down in there. And, once again, it's when cost really isn't a driver for this thing. You have all your die-cast metal. This is all, you've got lots of discrete stuff around here, and they're not going for the same sort of integration that they were with this consumer price point. I love doing teardowns of these things over time and seeing the progression. So hope you learned something from that. It's very interesting to see a cost-based, design constraint as opposed to a performance and rugged-based design constraint over here, whereas price, not a huge factor really. So anyway, I hope you found that interesting and useful. If you did, as always, please give it a big thumbs up, discuss down below, and follow me over on library.tv. Link down below as well. It's where it's all happening now. Catch you next time.